There are two circuits below that are capacitors that have capacitance values such that A is greater than B, which is greater than C. For each circuit ranked from greatest to least, the energy stored in the capacitors, the charge on each capacitor, and the potential difference across each capacitor. First, I'm going to start with the things that are the same. I know in parallel that A, whoops, I know in parallel that A is going to equal B, which is going to equal C, because the voltage potential difference is going to be the same. I know that in series, the charge is going to be the same for each one. So A is equal to B, which is equal to C. All right, now for the energy, since the voltage stays the same, I want an energy equation that has the capacitance, because that's what they gave me, was how they ranked, and the voltage, because the voltage stays the same. So in this case, I'm going to look at the equation that says E is equal to 1/2 CV squared. Now, since the voltage stays the same, that's going to go away, and the half is going to go away to create my proportionality. So that means that E is proportional to C. So whichever one has the greatest capacitance, that's going to have the highest energy. Let's see. So A is the greatest, so that's be A greater than B, which is greater than C. Now, the charge, I know that for a capacitor, C is a ratio of charge to voltage. Therefore, the charge is equal to C times V. Now, for each one of these, V is going to be the same. So that means that the charge is going to be proportional to C. So the bigger the capacitance, the more charge it's going to have since they all have the same voltage. So that means that A is greater than B, which is greater than C. All right, let's look at the ones in series. I know they all have the same amount of charge. Let's compare the energy. So for the energy equation, I know I want an energy equation with C in it because they gave me the capacitance, how they ranked, and I know that the charge remains the same, so I want an equation with C and Q. So E is equal to 1/2 QV is our equation. And in this equation, the half doesn't matter for the proportionality, and the charge doesn't matter for the proportionality. So what does matter is the voltage. So E is proportional to the voltage for the energy. Now, what I know about that is that the voltage of the smallest, how can I say this? The smallest capacitor will have the largest potential difference across it. So that means that the smaller capacitor, which is C, is going to be greater than B, which is greater than A. So in series, the smaller the capacitor, the larger the potential difference across it. That also leads me down to B with the voltage. Now, how I know that is because the voltage is defined by Q over C. Since Q remains the same for each one, I know that it's the inverse for the proportionality. Voltage is proportional to the inverse of C. And that's how I knew the smaller the capacitor, the larger the potential difference. So C is greater than B, which is greater than A.